Hey everybody, I hope you're having a good evening. We just watched the United States get gold and silver in a women's swim meet, and we watched Simone Biles, and it is a really nice night tonight. I got some questions in class about factoring quadratics when the lead coefficient's not equal to 1, and so I want to give you a really quick short tutorial on how to do that. So let's take a look. First of all, when the lead coefficient is equal to 1, I think you all can work these without too much problem, but there are some similarities here that I want to look at, that I want to show you. So let's take a look at this. Okay, you probably know that you're going to look for numbers that add to be 7 and multiply to be 12. And if you think about it a little bit, those numbers are 3 and 4. And so you can turn this into x plus 4 times x plus 3, sure enough. And if we were to check that using FOIL, my x times x is x squared. My outside is x times 3, so that would be 3x. My insides are 4 times x. That would be 4x, and my outsides are 12. And the thing to note, of course, that 3x and that 4x add up to be the 12. Or excuse me, it add up to be the 7. Okay, so I want you to note here what's going on is that really what we're doing is trying to figure out a FOIL backwards when we do this. So when we talk about numbers that add up to 7, that's why they add up to 7, because the outside and the inside have to add up to 7 in our FOIL. When we multiply by 12 here, that's because over here at the end, my lasts are my outsides, are the things that multiply out to be 12. So that's what we're trying to do when we do this. We're just FOILing backwards somehow. Now, there's another thing I want to show you called factoring by grouping. Okay, and this again is FOILing backwards. Okay, so notice right here I've got x squared plus 3x plus 4x plus 12. That's what we had up here, but when I ran this through, x squared plus 3x plus 4x plus 12. Let's talk about how we can look at the factorization when it's in this term, in this format. Sometimes when you're lucky, if you have a polynomial with more than 3 terms in it, you can factor parts of it and have a piece that looks common to both of both parts. So here's what I mean by that. In this case, if I factor an x out of the x plus 3, in the first 2 terms, I get x times x plus 3. In my second 2 terms, if I factor out a 4, that also leaves an x plus 3. So notice that those 2 things are exactly the same. So what I can do is I can factor that out also. X plus 3 can be factored away from this whole thing. When I factor it out of this part, it just leaves an x. And when I factor out of this part, it just leaves a 4. And what I get is x plus 4 times x plus 3. Here's another example that's a little sneakier. Okay. So when I look here and here, if I get lucky and factor these, that I'll have the same factor that's common to both pieces here. So let's cross our fingers and hope. Let's see, in the first piece I'm going to factor out a 4x, and that's going to leave an x minus 2. And in the second piece I'm going to factor out a 6, and that also leaves x minus 2. And sure enough, those 2 things match. If they don't match, you can't do this, but if you get lucky and they match, then you can. So I'm going to factor out the x minus 2. And when I factor it from here, that leaves a 4x. That's a plus. And when I factor it from here, that leaves a 6. So this becomes 4x plus 6 times x minus 2. And if I were to check this with foiling, 4x times x is 4x squared. My outsides, 4x times minus 2 is minus 8x. My insides are 6 plus times x, which is plus 6x. And my lasts are 6 times minus 2, which is minus 12, which is exactly what I had up there. Very cool. So now let's talk about how to factor this quadratic. Okay, there's the quadratic that was asked about in class. So that's the one we're going to try. And I'm going to use a method called the AC method. So I've got a quadratic. In this case, the A is a 7, the B is a negative 17, and the C is a 6. That was the example asked in class. So the idea is I'm going to split up the B term. I'm going to try to make it, instead of having 3 terms like this, I'm going to try to make it look like it's got 4 terms, and then I'm going to use factoring by grouping. So I have to figure out how that B term can be split up so that factoring by grouping will work. And the method that I use is called the AC method. It's very similar to what we did in the very first example, where we tried to find numbers that added to the B and multiplied to the C. The only difference is now, instead of multiplying to your C term, they have to multiply to A times C. But just like before, they have to add up to your B term. So let's try this out. My A is a 7. My B is a negative 17. My C is a 6. So my A times C is 7 times 6 is 42. So I want numbers that multiply to 42 and add to negative 17. Now, it's not always easy to see these right away, so here's what I do, is I go number 1, number 2, sum. So if my first number is a 1, remember they have to multiply to 42, so my second number would have to be 42. 1 plus 42 is 43. That's not equal to B. B has to be negative 17, so that won't work. So let's try if my first number is a 2. Let's see, 42 divided by 2 is 21. These two have to multiply to 42. So that's how I'm finding the second number, is I'm just taking 42 divided by the first number. So that's 21. And if I add those together, 21 plus 2 is 23. And that's not equal to negative 17. What if my first number was a 3? Let's see, 42 divided by 3 is, I don't know what that is. That'd be a 30, is 14. Oh, this is looking hopeful. 3 plus 14 is 17. We need negative 17. So what if I adjusted this to be negative 3 and negative 14? They'd still multiply to be plus 42, but they'd add to be negative 17. Those are my two numbers. There are my two numbers, negative 3 and negative 14. So you see what I'm doing? I'm just taking numbers, just 1, 2, 3, 4, 5, 6, 7. And then for my second number, I'm taking my AC divided by my first number. And then I'm checking to see if they add up. And if they do, then I'm good. And if I go through everything all the way up and can't find anything, then it just doesn't factor nicely. But here it did. So let's take a look. My two numbers are negative 3 and negative 14. Here's how I'm going to do this now. Whoops. There we go. Negative 3 and negative 14. So here's what I'm going to do. I'm going to keep my 7x squared. I'm going to change that to a negative 3x. I'm going to change that one to a negative 14x. and I'm going to keep my plus 6 at the end. So these two pieces came from there, but notice I didn't change the polynomial because they add up to -17. So no changes were made. I just rewrote it in a term in a way that's going to help me undo the FOIL. So now let's look at this piece, and let's look at this piece. It's very important now to keep these two pieces separate, and I'll put a little plus in the middle here. So in the first piece, the only thing I can factor out is an x, and that'll leave 7x minus 3. And in the second piece, I can only factor out a 2, and that'll leave -7x plus 3. These are not exactly the same, are they? But they're very close. This one is a plus 7x minus 3. That's a -7x plus 3. So what I'm going to do is change this. Instead of factoring out a 2, I'm going to factor out a -2. And that'll turn this into a 7x minus 3 when I factor that negative out. Now these two guys match, and here's my factorization. 7x minus 3 is one factor. That's the thing that I factored out. And in this piece, that leaves an x. And in this piece, that leaves a -2. So this factors out to x minus 2 times 7x minus 3. There's my factorization. And again, we can check it with FOIL. So x times 7x, 7x squared. There's my firsts. My outsides, x times -3, -3x. My insides, -2 times 7x, -14x. And my last, -2 times -3 is +6. Notice, isn't that exactly what I had up here after I split the b up? And if I simplify it, 7x squared -3 minus 14 is -17x. Whoops. And then my +6 at the end. So yep, it all checks out. So I hope this is helpful. I know it was pretty quick and I only did one example. Let me know in class if you want more examples, okay? Thanks. See you in class. Bye-bye.